All right, welcome, guys. Today I want to introduce to you the concept of the first principle, the building block behind the first derivative. So, at first glance, this formula can be quite intimidating, but once you understand that it is just an extrapolation from a very intuitive idea, which is the concept of the average gradient, then it becomes quite intuitive. All right, let's circle back a bit. So, what is the gradient? The gradient is simply the slope of a line, which can be calculated by the change in y divided by the change in x, which is represented in mathematics as delta y divided by delta x. Then the question comes, can you actually find the slope of a curve? And this proves to be difficult because if you come here and try to find the slope at some point here, you can see that we have, sorry about that, what we call a negative slope. And here we have a slope that is almost zero. But what we can do is at least find an approximation by saying what is the slope between 2 points. And as you can see, we calculate it as the average gradient, which is equal to the change in y divided by the change in x between those 2 points. Let's make things a little bit more practical. So let's say here that I have a car and I'm trying to track this car. One thing that I can do is to collect data on this car and say, on this side I have time and on the other side I have distance. So one thing I will record is that after 0 seconds, the car has moved zero distance. After 1 second, the car has moved a distance of 1 meters. After 2 seconds, it has moved a distance of 4 meters, and so on. And what I can do about that is to plot this on a graph. And in this case, we'll come up with this function f of x. And here, we are actually not interested in this part as we do not have negative time. Then, when we come here, we might say a very important parameter is actually the speed. So can I find the speed out of this? That proves to be fairly difficult, but one thing that I can do is to find at least an approximation of the speed by taking this. So I can say between this point and this point, I can approximate that the speed is the tangent, is the gradient of this line. But then we know that this car wasn't moving at the same speed when it was at 0 meters and when it was here, let's say somewhat 9 meters. Then we can say, okay, we are actually interested in the speed at least at some point here. Then, an idea we can come up with is that at least let us decrease let us decrease our delta x in order to find a better approximation than what we started with. We can come here and again we can say, okay, we were going to find our tangent line right here. But then But then, this is still just an approximation. One thing I can do if I'm not satisfied is to keep decreasing this line and say, okay, let me at least find the tangent line between this point. But then I can keep on decreasing my delta x and keep on decreasing my delta x until I get to a point where I can say, At any point, at any point x, the slope of the tangent line of the function f of x is equal to the limit as delta x approaches 0 of delta y divided by delta x. But delta y is just simply the change in the function f of x. But the change in the function f of x is just f of x plus x. No, it's just f of x at the point x plus delta x minus f of x. All of this divided by delta x. And I can say, let delta x equal to h, which brings me to my conclusion, which says, the first principle, the slope of the tangent line at any point x of a function f of x, which is represented by the function f prime of x, is equals to the limit as h approaches 0 of f of x plus h minus f of x divided by h. Thank you.